Welcome you all my lecture series of data structures. In today's video we are going to see about what is that topological sort, how to represents the graph in a linear ordering of vertices. So before going into that topological sort explanation, first we will see that what is a definition of topological sort. So topological sort is nothing but is a linear ordering of vertices in a directed acyclic graph such that if there is a path from Vi to Vj, then Vj will appear after Vi in the linear ordering. So this is the definition of topological sort. Suppose we have a path from Vi to Vj means Vj should appear after the visit of Vi. So this is an ordering of vertices. It is called it as a topological sort. So there is an algorithm to find a topological ordering in every graph. First step, find the integrity of every vertex. For a given graph, find the integrity of every vertex. And second step, place the vertices whose integrity is 0 on the empty queue. So the second step is place the vertices whose integrity is 0. The third step is dequeue the vertex V and decrement the integers of all its adjacent vertices. Suppose the integrity of vertex V is 0 means we dequeue that vertex. Okay, so after that decrement the integrity of all the adjacent vertices of V. That is the third step. Next, enqueue the vertex on the queue if its integrity is 0. So after decrementing the adjacent vertices, now find out what is the next vertex integrity is 0. If it is means place it that vertex on the queue. So repeat the process from the step 3 and 4 until the queue is empty. So finally we have a topological ordering is the order in which the vertices are dequeued. First we enqueue the vertex whose integrity is 0 after we dequeue. So once you dequeuing, find the adjacent vertices of that dequeued vertex and decrement the adjacent vertices in degrees. So that is the steps we have to follow to find the topological sort. So the finally we get one ordering vertices in which the vertices are dequeued. For example, consider this is the graph. This is the directed graph. First step, we should find the we can represent that directed graph in terms of an adjacency matrix and find the integrity adjacent of all the vertices. For example, the adjacent of A is B and C. So mark it as 1. The adjacent of B is C and D, so mark it as 1. Adjacent of C is D and adjacent of D is 0. So find the adjacency matrix of the given matrix. After that we find the integrity of all the vertices. For example, the integrity is nothing but incoming edges for that vertex. So in that adjacency matrix, column wise, the integrity of A is 0. So the integrity of B is 1 and C is 2 and D is 2. So next step in the topological sort, enqueue the vertex whose integrity is 0. So the vertex A integrity is 0. So enqueue the vertex A. So after enqueuing, again you have to dequeue the vertex A from the queue and decrement the integrity of all its adjacent vertices. So what is the adjacent of A means B and C. So the B and C integrity could be decremented. So the B is decremented as 0 and C is decremented as 1. Now find the whose integrity is 0 means the vertex B is integrity is 0. So we enqueue and dequeue and again repeat the process, decrement the integrity of its adjacent vertices and find the next integrity 0 vertex from that result. So finally we get the ordering of vertices like A, B, next is a C and D. So the result of graph is we are NQing A and DQ A and B, C and D. So the topological ordering of vertices is at A, B, C, D. So these are all the this is the step we have to follow to find the topological sort of every graph. So what I recap the steps again. First, find the integrity of all the vertices. So from that integrity, whose integrity is 0 means first select that vertex, NQ and DQ that vertex. So the first visited or ordering vertices is in A. Next is the find the adjacent of that DQ vertex and decrement the integrity of that vertices. So next step, find the whose integrity is 0 and find its NQ and DQ that vertex and find that adjacent vertices of in DQ vertex and decrement it. These steps to be repeated until we visited all the vertices. I hope you will understand what is the topological ordering of vertices for the every graph. Thank you.